Good evening, everybody, and welcome to the PushQuantum Quantum Entrepreneurship Laboratory. Thank you all for joining. Just want to indicate we have various streams of people in the calls. We have a Zoom meeting with the students and the jury, also with some extra observants who will also be able to ask questions in between. And we also have a YouTube stream. The YouTube stream should also be available after the demo day. So that people can still watch it and see what the students created. Our session today is going to look as follows. We're going to start with a general introduction, as well as an introduction of the jury. After that, we're going to get to the meat of the matter. We're going to be looking at the presentations of the pitches of the students. Every team of students is going to present for about 8 minutes. After that, there's the opportunity for Q&A, mostly from the people in the jury, but also from the other people in the Zoom. After we've had the 4 pitches from the different student teams, we're going to do a short outro and end the formal session. But we will create breakout rooms where the students will be divided, and anybody in the Zoom call will be able to go into the breakout rooms themselves in order to ask additional questions to the particular student teams. Good. Then to get started about what is the Quantum Entrepreneurship Laboratory. It all started a couple of months back in September, October, when we set out to ask for applications from students. We received over 200 applications coming from a whole range of universities, but primarily from the Munich area, the Technical University of Munich and the Ludwig Maximilian University. Students are also at the various industry companies already. And from there, we also had some very promising candidates. From this pool, we selected a total of 20 participants to join us at the Quantum Entrepreneurship Laboratory. And they participated in a semester, so that's in academic terms half a year, in order to address one of the 4 challenges we posed to them. The 20 participants were split up into 4 different teams, and every single team was formed based on the skill sets of the students and their preference. Every team has 2 quantum natives, 2 business developers, 1 software engineer, and they are paired with an industry partner that is providing them with a challenge. We will discuss them in more detail in a moment. Throughout the semester, the students went through 5 different phases. It started with a first week, which was the kickoff, which was the bootcamp. In this bootcamp week, every evening there were lectures, and every evening there were network events, which we all had to do digitally, unfortunately. Still, the students were able to meet one another and provide their preferences for which of the teams they wanted to be formed in, and which industry partner they wanted to use as a sparring partner for their ideas. After the bootcamp, the students went into the ideation phase. They were provided with a high-level challenge, but now needed to figure out what is the problem of their challenge partner, what could be possible solutions to the problem, and how can they make this into a product and create an actual startup out of this. Once they started zooming down and coming up with an actual product, they went into the prototyping phase. In the prototyping phase, they started to build the actual proof of concepts. At the end of the prototyping phase, they had the midterm exam in a similar structure as today, but of course, not as far advanced yet. They received feedback, and based on the feedback, they could go into the refinement phase and then work on the final deliveries. This course was organized by a whole range of people, and we received a great amount of help for this, which we would like to make sure to acknowledge. First of all, the academics from the Technical University of Munich, from the schools of informatics, management, and physics. The academic coordinators, Isabel and Christian, and the academic advisors, Stefan and Frank. The challenge partners that assisted the different student teams were Corey from E.ON, Martin from Volkswagen Data Labs, Leanne from Airbus, and Thierry from Airbus as well. Throughout the semester, the students received lectures from invited speakers. We are very grateful to the speakers that they were able to provide time to us. These speakers were leading experts from industry and academia and provide us with insights both technically or from the business side. The students were also assisted through a great team of teaching assistants, Aritra from Delft University of Technology, Marina from Technical University of Munich, as well as Remy, and Alyssa from the Free University of Berlin. Last but not least, there is the course organizing team. That would be Raoul and myself, as well as Benjamin, Vladimir, and Georgos. We are all part of a non-profit organization called PushQuantum, which is something that Raoul will be telling us more about. Raoul, please go ahead.
Excellent. Thanks for the great introduction, Tom. So the value proposition in this case is clear. At PushQuantum, we offer interdisciplinary, real-world focused education that enables students from all disciplines to enjoy successful careers in quantum technologies. And although this is quite a high-level description, how we specifically deliver these results looks pretty much like this. Please go on to the next one. Excellent. So PushQuantum is the community that accompanies you in your quantum journey, from zero to quantum hero, and how we contribute to your further development pretty much depends on the specific point at which you are in your quantum career. What is clear is that since the very first day, you will be part of a vibrant community where you will have the chance to meet other talented students from all disciplines, but that all are joined by a common passion for quantum technologies. At PushQuantum, you will take part in seminars, workshops, and university courses that will allow you to further deepen your quantum skills. And on the organizing side, we work hard to guarantee that once you feel confident about your quantum skills, there will be further opportunities to collaborate with industry, academia, and startups. And if flying on your own is your thing, we also make sure that you have the right contacts and the right toolset in order to bring your quantum ideas to market. Next. Good. And just by hearing how do we actually deliver this, you probably are already wondering, wow, how can I actually push quantum? How can I contribute to bring quantum technologies further? Students in the room, there are several ways to do this, and they go in ascending levels of commitment. The first of them is just by joining our community, in which you can keep learning about quantum technologies and connect with your fellow peers that will be the ones shaping the field in the years to come. Next up, you can create even more opportunities both for yourself and for your colleagues by taking part in the organizing teams that make happen our different offerings, such as workshops, webinars, or even paper discussion groups. And last, when you're hungry for more, the step could be to take part in the organizing team of PushQuantum, our board, that is currently taking an active part in shaping quantum education in Munich, and will work hard during the next semesters to come into making Munich the quantum hub of Europe. Now, this doesn't stop here. For you companies, members of academia, and also startups, there's also further ways in which you can engage. This was the first of many Quantum Entrepreneurship Laboratories. Therefore, we are already evaluating what could be the optimal challenge partners to engage with for the coming teams that are going to be participating in the Quantum Entrepreneurship Lab. Next up, also PushQuantum started in Munich, but we are not going to limit our scope of actuation only to this city. Our plan is to turn PushQuantum into an international network, and therefore we are looking for people to drive this initiative forward in other universities in other corners of the world. Currently, we are in discussions with representatives from MIT, Cambridge, and University of Toronto, amongst others, in order to make this happen. And we are looking people from both the student side and the company and academia side in order to support these local initiatives further. And last but not least, if you like the pitches that you hear and also support the way in which we encourage interdisciplinary quantum education, you're more than welcome to offer our students further opportunities and reach out to them. So for any kind of questions or any further discussions that you would like to have with us, we are readily available to you just at an email that you can find in the bottom part of this slide. Good, but we're here for PushQuantum, for pushing quantum, but we are here to do it in a very specific way. The ones that really have been pushing quantum over the last couple of months are our students that have been working really hard, guided by world-class experts, into defining different user-centric quantum products. However, in the end, the time comes to define how successful we were in this journey. And we are lucky enough to count with a panel of world-class experts that will be evaluating the pitching of the different pitches of the teams that have taken part in our Quantum Entrepreneurship Laboratory. And before jumping further into the pitches themselves and explaining a bit about the different evaluation criteria that we are going to use, I would like to give the stage for a couple of sentences to each of the members of our jury, and I state once again that we are really grateful for their participation. So let's go in the same order, left to right, as we see in the slides. So if you are available, Thierry, the microphone is yours.
Thank you, Raul. Hi, everyone. Good evening. Happy to be here. Thierry Bottet, head of Airbus Blue Sky. Over the last few months, I had the pleasure of supporting and working with QDynamics. Looking forward to their presentation this evening. And I'll finish off simply by thanking you, the organizers, PushQuantum. Fantastic initiative. Happy to have been a part of it.
Thank you, Thierry. Stefan?
Hey, my name is Stefan Philipp, also happy to be here. I'm working, so I'm professor at the Technical University of Munich and at the Walter Meister Institute. I'm happy that you have organized this theme, and the thanks goes all to you. And so with that, I am enjoying and looking forward to the talks.
Mm-hmm. Good. William, are you readily available or? Okay. Doesn't seem like it. Then the stage is for Christoph.
Hello. Hi, this is Christoph. So I'm Christoph Josek. I'm founding partner at Quantum Nations. We're an investor in quantum technologies. It was really a pleasure to participate to one of the sessions and share our views on funding startups. And I'm really excited to be here tonight and love nothing more than to see a company coming out of these bright young students. Thank you.
We are also really happy to have you with us. So thanks, Christoph. And now the microphone goes to Andre.
Good morning from Miami Beach, where the sun is shining. Nice to see so many familiar faces. I'm the CEO of Interference Advisor, a data and analysis provider in quantum technologies, the chairman of One Quantum. Similar to PushQuantum, we build communities globally in quantum tech, as well as the managing partner of Entanglement Capital. I've founded and exited 5 startups in artificial intelligence and digital, have been a mentor at Techstars, the German accelerator, and General Assembly, and I have an MBA in economics from University of Chicago and studied quantum at MIT, and excited to hear the pitches.
So we are Andrea. Thank you very much. Next up, Martin.
Yeah, thank you. So my name is Martin Leib. I'm from the Data Lab Munich. So our job is to promote quantum computing within the VW group. And I'm also, you already introduced me, so I'm the industrial advisor to 2 of the teams that are going to present here.
Wonderful. Thanks, Martin. Then Christian, the mic is yours.
Yeah, good evening, everyone. Thanks again, first of all, to the organizers again for setting up this wonderful course. My name is Christian Medleb. I'm as a professorship for quantum computing actually at the TU Munich in the informatics department. And I'm looking forward to the talks, of course.
Thanks, Christian. Corey, please.
Yeah, hi, everyone. So my name is Corey. I'm leading the quantum initiatives at E.ON Digital Technology, and specifically the division is advanced analytics and artificial intelligence. And as was already mentioned, so I was the industry partner team lead, I suppose, of ElectriQ with a Q at the end. Yeah, I did my PhD here in Munich at TUM some years ago. So I'm also native. Yeah, thank you.
Thanks a lot, Corey. Frank, next up.
Yeah, hi everyone. My name is Frank Pollmann, and I'm heading the Condensed Matter Theory group here at TUM. And as part of our work, we are trying to understand how to use modern quantum computing, quantum technology for understanding our problems. And yeah, big thanks to PushQuantum and everyone involved for putting all this together. So looking forward to the demos.
Thanks a lot, Frank. Denise, please take the stage.
Hi, everyone. Denise Ruffner, VP of Business Development at IonQ, as well as President of Women in Quantum, coming to you from Southern California, sunny Southern California. I'll dig it in. And thank you for including me. Looking very much forward to hearing the talks and discussing the potential businesses that you're developing. Thank you.
Thank you, Denise. Then, last but not least, please, Guillaume, go ahead.
Hey, I'm Guillaume Verdon. I'm a research scientist and product lead here at Sandbox at Alphabet, working on a team within Alphabet working on quantum and AI technologies. Before joining Sandbox, I was at Google Quantum and co-founded the TensorFlow Quantum project. Really looking forward to the pitches today.
Thanks a lot, Guillaume. And then, after going through each of the members of our wonderful jury, we want to give you some insights into how are we going to be judging the different pitches that the teams present. There's going to be 4 different sections in which we are going to be rating the teams. The first of them is how well did they manage to define the problem, the specific problem that they aim to tackle with their startup. And this part also includes how well did they manage to define the specific target market and customer for their inventions. Second up, there's the definition of the solutions that they have came up with. Did they formulate a compelling value proposition? Did they get to deliver the value add for their customers in a clear and plausible way? Next up, we are also evaluating the technical feasibility of their inventions. So are they aware of the classical solutions that solve similar needs? And also, are they aware of the prior art existing in quantum solutions for it? And last, we will also be evaluating them based on the business prospects of their inventions in different aspects, such as what does the roadmap to profitability look like? How are their unit economics? Or what is the actual plan that they have in order to reach the break-even? So is this well-defined by means of a set of milestones? And have they defined objectives and key results enabling them to get there? We want to see clarity in the execution and also an overall well-rounded product that has some market potential. And with this, I think that it's enough talking on the organizing side, and it's time to welcome onto the stage the real protagonists of the evening, which are the teams that have been working hard and brilliantly over the whole semester. We count with 4 teams that will be presenting their ideas today, and the first of them to take the stage is Dirac Dynamics. Dirac Dynamics have came up with a compelling logistic optimizations solution, and will be telling us more about how are they helping dispatchers on their day-to-day work. And with this, I invite the members of Dirac Dynamics to start sharing their screen, and go ahead. Best of the lucks.
Thank you, Raul. I'll start sharing in a second. All right. We live in a world of growing and accelerating motion. In Dirac Dynamics, we believe in the power of this exploding mobility and connectedness. However, we're also aware that increasing movement comes at a higher environmental and economic cost. And that is why, using the power of quantum technologies, data, and analytics, we aspire to make mobility more efficient, one vehicle at a time. And to do that, we want to start with the logistics of road freight. Why road freight? Because it's very inefficient. 1 out of every 5 miles driven by trucks on the road is empty. This amounts to almost $30,000 wasted per truck per year because of empty miles. And for an average fleet size of 2,000 trucks, this problem can reach the magnitude of $60 million that just go down the drain. The question is, why does this happen? To understand this a bit better, let's walk through a day in the life of a typical dispatcher in more detail. So meet Yannis. Yannis is a dispatcher working for TruckCo, a fleet company of 50 vehicles. Every day, Yannis is responsible for matching a batch of 15 to 20 trucks to incoming orders in order to maximize fleet utility and minimize inefficiencies. But this is hard work. In order to match trucks and orders, Yannis has to manually handle multiple Excels at the same time. And when orders come in, he has to cross-check between order constraints, order requirements, fleet positions, and so on in order to make the matches. It is quite messy. And what makes this problem, the batch matching problem, even more difficult is the fact that the optimal allocation of a single truck depends on the allocations of all the others. So while a simple and intuitive solution like just picking the nearest truck order pairs and allocating those, well, that seems good, it's actually suboptimal. The optimal solution to this problem, the one that minimizes empty miles across the entire fleet, actually takes into account the interdependence of trucks and is therefore complex. And for Yannis, as fleet size grows, the problem just gets even worse. So the question is, why not just automate the whole thing and remove Yannis from the equation? The problem is you can't. Because for companies like TruckCo, operations rely on the critical link between dispatchers and drivers. So just removing Yannis from the equation is not suitable. But what if a tool could augment Yannis' work instead of eliminating it? That is where Roam comes in. Roam is a bespoke software platform designed and built by Dirac Dynamics in order to enable truck companies to optimally match trucks and orders in order to minimize empty miles across the entire fleet and drive efficiencies. And who better to tell us more about it than Yannis himself?
Hi, I'm Yannis, the dispatcher working for TruckCo. My day-to-day job is to assign orders that pop up during the day to the trucks in the fleet I manage. It's very complicated to find an optimal matching truck for each order in this dynamic environment. Roam is built to make it as simple as possible for me to find a matching that minimizes the total miles driven by the fleet. When I open Roam, the first thing I see is a map with the location of all trucks in my fleet and all the current orders that have to be picked up. When doing the matching manually, I'd usually come up with a solution where I mostly assign each order to the truck, which is currently closest to it. This seems intuitive and is simple to do, but that does lead to a suboptimal solution. In the given example, the last truck that was matched with an order would need to travel a long distance for the pickup. Roam allows me to find better solutions with just the click of a button. When clicking the button, Roam will run heavy optimization algorithms in the background for me and display the solution it found on the map. For the given scenario, this reduces the overall driven miles down from 39 to 34, an improvement of 13% simply by clicking a button inside Roam. I can also get a list view of orders and trucks to check their information and update their status if necessary. Last but not least, Roam offers a dashboard with the most important KPIs to me and my company. And that's it for the demo of Roam. As a dispatcher, it makes my day-to-day job much simpler and helps me to optimize my fleet utilization easily.
As you just saw, Roam enables dispatchers to optimize fleet allocation and drive efficiency for their companies in 3 key ways. First, it provides real-time optimization of batch matching that makes dispatchers' lives easier. Second, it streamlines the constraint checking and other diligence dispatchers have to do, so they can focus on communicating efficiently with their drivers. Third, it increases the visibility of the fleet and will provide insight into potential demand in the future. Most importantly, Roam focuses on winning over dispatchers like Yannis by empowering them and not replacing them. On top of that, Roam drives efficiency by reducing the driven empty miles by an average of 10%. Behind the scenes, Roam works on a modular optimization architecture of 3 components. First, the vehicle routing. Second, the batch matching. and later on, the predictive demand analytics.
Because of the computational cost of the three components, scaling this optimization across thousands of trucks in a fleet simultaneously is difficult. To enable real-time value delivery, we break truck fleets down into batches of 15 to 20 trucks, managed by a single dispatcher, and optimize those. To take into account thousands of trucks, many more constraints, and generate holistic reductions in empty miles for entire fleets, we need something much more powerful than the classical computers. That's where quantum comes in. We need a quantum leap. We have good news. This is a leap we have already started. We have successfully formulated and run the batch matching problem you just witnessed on a quantum annealer. Because hardware bottlenecks limit our quantum algorithm scalability, our first deployment will be classical. However, we are determined to establish a strong quantum advantage in the market by actively refining these algorithms on quantum annealing machines. This will put us in a prime position to upgrade Rome to gate-based quantum computers when they arrive.
But besides from our quantum proficiency, how do we differentiate from our competitors? As you can see here illustrated, most of our competitors are focused on backwards analysis and automation. We, in contrast, deliver cutting-edge predictive functionality to maximize the added value for our customers. Furthermore, we focus on a user-centric augmentation of processes to leverage a fast adaptation among our customers, especially the dispatchers. Moreover, we incorporate a strong business model, charging our customers a competitive price of $25 per vehicle in month and expecting an average fleet size of 50 trucks per customer. We obtain a monthly recurring revenue of $1,250 per customer, while we are saving them more than $11,000 per month. So there's huge incentive to use Rome. But we do not only save money for our customers, we also help them to decrease CO2 emissions and to operate more environmentally friendly by reducing the overall miles driven. We set high goals for ourselves and want to reach a milestone of 100 customers by 2024, 3 years after our product launch. Here you can see our unit economics, demonstrating our efficient way of operating at a gross margin of around 80%. We also see huge market potential for our solution. Based on logistic companies' annual spending on data and analytics software, we target a service obtainable market of around $125 million. So, all in all, this enables us an aggressive but also peer group related revenue growth of around 70% after reaching our milestone of 100 customers in 2024.
We are a qualified team with backgrounds in finance, computer science, quantum computing, and prior startup experience that are key for driving this vision forward. Most importantly, together, we combine the right skills necessary to advance our commercial and technical visions and make Dirac Dynamics a success. This, we believe, is a unique opportunity. We are a qualified team determined to address a critical problem in a growing market through a great, scalable, and profitable product. Yet for us, road rate is only the beginning. We aspire to put Rome at the center of all roads, extending its value generation across multiple use cases, including last mile delivery, public transportation, peer-to-peer delivery services, and ride-sharing, and in the future, autonomous vehicles, when the time comes. This will allow us to encompass multiple and complex schedules, ranging from that of goods, to drivers, to vehicles, to traffic, and much more. It is in these complex environments of interdependent schedules where we believe the power of quantum computing can really generate value. It is in these complex environments of interdependent schedules where we want to leave our mark. We are Dirac Dynamics, and we are on a mission to make mobility more efficient. Thank you for your time, and we welcome feedback, questions, and any comments you might have. Thank you.
Thank you very much, Dirac Dynamics. That was a great presentation. Let me just say a couple of words on how the questions can be asked. It would be best if people use on the bottom of the screen the button reactions and raise hand so that they can see who would be wanting to ask the next question. While people start finding that button, I also wanted to say the students just presented us with an investor pitch. Next to this investor pitch, they will be sending us a technical report where they discuss the technical intricacies and a business report where they will be telling us more about the business plan. Very good. I see that Stefan has raised his hand. Stefan, please go ahead.
Hey, thanks. So thanks for the very nice presentation. So I would have a question when it comes to your break even and the revenues that you showed that you will create. Does this also include the estimated cost of using the quantum annealer and the quantum computer? And this is taken account into the time scales?
No, this was just as we are operating now our standard product. So there's just basically API costs involved, so not the quantum annealer.
Okay, thanks.
Thank you. Next up would be Frank.
Hey, nice presentation. It looks to me like the requirements of this application on availability, short latency, and reliability of quantum computers are very high. So in other words, that you have a very short time window at which the quantum computer really has to work. Is this true, and how long is the time window? So, you know, quantum computing hardware is finicky. It could be that it's up for maintenance every now and then.
So we start right now with the classical solution that calculates our problems, and we just implement our algorithms on a quantum machine right now to test it and to stay on track with the development of quantum machines. And then we'll, in the future, when the quantum devices are ready, use them for the calculations we're doing right now. So for now, we use them as a testing machine and then upgrade our algorithms onto the quantum machine when they are ready.
Okay, thank you.
Thank you for the question. Next up would be Andre, after that TRD.
Thank you, Tom. Great presentation, very well presented, which is super important. My question will be about your go-to-market. 100 customers, 2024, that's a lot. And you know, the revenue per customer is not huge. But more importantly, how do you plan on getting those customers, especially in your early classical phase? What's your sales and marketing?
So throughout our development process, we were talking to potential customers, and so we have no clear assignment of customers yet, but we are still in talks with these companies, and they showed that they're very attracted to the software, and we're still in talks with them. And so our ramp-up period is based on our peer group. So we looked at how did our competitors in the market grow, so the startups that are currently located in this market, and we orientated us around this growth, and we want to show a similar growth rate throughout this process.
Thierry Bottel from Airbus speaking. Great presentation. Question about that customer base that builds a little bit on Andre's previous question. What has been some of the preliminary feedback from customers, in particular, how your approach sort of differs, augments the types of tools they already have?
So to answer your question, the feedback we've gotten was very much geared towards what the different features they would require. I think what is very much appreciated from gauging from the feedback that we received and that informs our development is the fact that a lot of the times when dispatchers are working on these allocation, they have to, or there is a confusion among, cross-checking different Excels, cross-checking different requirements. And the main thing that is appreciated is not only the optimization, that is a great thing to have, but also the streamlining of the whole workflow. So we couldn't tell you right now with certainty, we have received X, Y, and Z feedback because we're still developing the MVP and we want to present it when it's best displayed. But the key value points that they appreciate is the streamlining of the workflow and the optimization.
Perfect. Assuming that answers your question, Terry, then next up would be Frank. After that, Denise.
Hi. Yeah, it was a really great presentation. I have a bit of a technical question. Like for this specific problem that you have to optimize, is it obvious that a quantum computer would give us an exponential speed up or a speed up at all compared to classical computers? Or is it a BQP problem?
So it, of course, depends on which algorithm you use or which method you use to solve the problem. And with quantum annealer, you would have like at most a quadratic speedup, and that's not like sure yet. So we will investigate like further down the road, depending on quantum gate models and their potential speed up for the solution. But the problem itself is also, if you have a one-to-one matching, then the problem seems to be not NP hard, but if you have like a matching with multiple, for example, one transportable, multiple carriers, and you have independent schedules, whatever, that explode in complexity pretty fast. And even the quadratic speed up could help here in the future to solve the problem faster than classical algorithms.
Mm-hmm. Thank you.
Thank you, Frank. Next up would be Denise.
Hi, I'm going back to Andre and Thierry's question about customers. Kind of scaling to 100 customers is in a relatively short period of time. I'm wondering what plans you have for how you're going to do it.
Mm-hmm.
I know you've had preliminary discussions, but do you have a salesperson? How are you going to do that?
Right. So to answer your question, two things. First, regarding the overall feasibility, something that can paint a better picture to what we expect in the 100 customer or the 100 customer mark in 2024 is the size of the market in Europe and elsewhere, which we're targeting, mainly the US and Europe. 100 customers would amount to 5,000 trucks, and right now in Europe we have 11.5 million. So we think that it's a low number. I mean, 100 customers is high, but it's a low number relative to the overall market. And we have some key geographies we can walk through the expansion plan. The key point we have right now is we want to expand first in Germany, leverage these connections. We think that, well, from the feedback we've received, actually, this is a tight industry. Efficiencies and margins are critical. Margins are very low. So we think there is a word of mouth component that would be valuable. However, to answer your question precisely, no, we don't have a salesperson yet on board. Our roadmap right now is developing the MVP and validating that with customers, and then building upon it in terms of new features and other different things that would be required to launch in the market. So at that point, we have greater clarity. But we do think the market in general is big enough for this approach, and we expect that even in Germany alone, we could reach 50 to 60 customers based on these sizes and based on the characteristics of Germany on the whole market. Germany operates at shorter distances, has higher portions of the overall European market in road freight based on ton-kilometer metrics. So we think it's viable.
Okay. Thank you.
Perfect.
Hey, Hurley, I see you popped up.
Yeah, I didn't raise my hand, but I'd be happy to add a question on yours, but I think Christian's next, right?
Yes, if Christian could do his question, and after that, please go ahead.
Yeah, thank you. So I just would have a more also technical question more on the algorithm side. So maybe can you share a few ideas which kind of algorithms are you planning to use? Or, I mean, for example, you mentioned both a quantum annealer and a circuit-based quantum computer, but I guess the type of algorithm would be different, right? I mean, just in general, do you plan to formulate this as a quadratic Kubo problem or as or solve it with QEL, or, I mean, what is just a general direction for the algorithms?
Yeah, so for now, we formulate the problem as a Kubo because it has the advantage that we can use it for the quantum annealer and then for near-term quantum algorithms like the QAOA. We would need to refine it, of course, for that. But yeah, later down the road, we can also investigate other algorithms like the Grover adaptive search, for example, might be a feasible option for it. So yeah, that's our roadmap so far.
Okay.
Next up would be Hurley, and that would also be the final question.
Yeah, so my question is related to the sales question. I'm less worried about that with startups and very worried about support. So you mentioned these 100 customers. Support is the cost in a business that startups rarely think about or look at that usually can come back to haunt them, right? So have you thought about the support model, the cost of that, what support issues you might have with deploying this?
To answer your question, William, we have analyzed it on a preliminary basis. It's difficult for us to forecast on a very clear basis, 4 years out, any SG&A and try to get to an EBITDA and a cash flow from that perspective. mainly because, again, we're still in the MVP stage, so we don't have that clarity. We think that because of the characteristics of the industry, that'll be a very important point, because again, many of these players rely on very old technology, if any technology at all. Many solutions are based on pen and paper, Excel at most. So there is definitely a more, human capital heavy sales process going on. But as we gain further clarity after the MVP and more talks with customers and seeing how quickly this could scale in the market, we'd have greater clarity and could answer that question in more detail.
Okay, so just to be clear in your answer, kind of not there yet. You want to have those conversations. You're going to look at the sales model, what you think you can actually deploy first, and then you will be looking at the support model and the costs from the impact on that, right?
Exactly.
Okay,
that is correct. Yeah.
Perfect. Then Dirac Dynamics, thank you very much. We really appreciate your presentation. The next student team can start sharing already. Perfect. And the next team that will be taking the stage is ChargeQ. ChargeQ, please go ahead.
Okay. Hello, everyone. Let's go. We are ChargeQ, and we address the future challenges of electric mobility with quantum algorithms. For the start, the essential question one needs to ask is, what will happen to the energy grid as more and more electric vehicles are hitting the road? Blackouts will become more likely. Studies by leading consulting companies have already shown that an electric vehicle rate of 30% will lead to significant hours of blackouts. This situation could be our daily struggle unless utility companies are investing billions of euros into grid infrastructure by 2032. To understand why, imagine a local grid in your neighborhood. An average grid serves 120 households. A grid of this size can only handle the charging of 36 electric vehicles. So if your neighbor is buying a brand new Tesla, you can't. Otherwise, there will likely be blackouts. Let's look at an example workday to understand the problem better and find out how we can solve it. The black line represents the amount of power that is requested at each time of the day. The green line represents the overall power consumption while taking electric vehicles into account. The impact of electric vehicles leads to peaks when everyone comes home from work and wants to charge at the same time. While the total energy increases only by 35%, the capacity needed at peak times is estimated to be 100% higher, leading to an estimated required investment as high as $5,800 per electric vehicle. And here, we can save 70% investment costs for our customers. With an optimized charging schedule, the peak capacity can be distributed efficiently while ensuring both a minimum load and everyone's traveling plans. This is a difficult problem. Therefore, we ChargeQ use quantum computing to help distribution system operators manage the load in their power grids. Exactly this is our value proposition. DSOs want to prevent costly electricity peaks. They also want to know at which time their customers are charging. We prevent costly electricity peaks for DSOs using smart load scheduling and generate valuable data about energy consumption by using machine learning models on individual charging profiles. In the end, all of this will enhance the widespread adoption of electric vehicles, making urban life better for everyone. Vivi will show you now how our product works in practice.
Thank you, Philip. So let's look at this charging station. Let's say Charlie arrives with his car that's almost empty. He doesn't need his car until the next morning. And so his car starts charging. Now Granny arrives. Granny needs her car in 2 hours to get back home. However, there's a big problem. The local grid is already at capacity. This is a problem for DSOs because peak prices are expensive, but even more expensive are outages. So in order to prevent an outage, the DSO is forced to only charge one car at a time. And 2 hours later, Granny has to realize that her car hasn't charged at all and she can't get home. But with our solution, this would look different. Now, Charlie and Granny use the ChargeQ MyCharge app. This app helps users enter their charging needs, so we can estimate how much charge they need and when, and ensure these needs are met. The app data is then sent to the ChargeQ scheduling service. We use this data to calculate an optimized charging schedule. This is a known NP-hard problem where existing classical approximation algorithms already struggle at 10 charging jobs. But we use quantum computers to do that. The charging schedule is then sent to the DSOs, who can use our software to manage these schedules and enforce them on their charging stations. Now, both cars are charged sufficiently until they need to leave, and Granny can get back home in time for their family dinner. So this is what we promise. To end users, we promise that their cars are charged sufficiently until their departure time, but at least 20% for emergencies. And to DSOs, we promise that their local grid is stabilized by providing them with an optimized charging schedule and therefore saving money. So now that you've understood what we do, my colleague will give you a deeper dive into the market.
Thank you. With the product Vivi just showed you, we are operating in the multi-billion euro electricity infrastructure market. The advent of electric cars is not the only challenge utility companies are facing in the near future. Switching from fossil fuels and nuclear power to renewables will also lead to a more variable supply of energy. The International Energy Agency, IEA, estimates that utility companies worldwide will invest the equivalent of 270 billion euros every year from now through 2035 to get their grids fit for the decarbonized future. With our solution, we specifically address the smart charging market. Philip already mentioned that utility companies can save thousands of euros in infrastructure investments per electric vehicle by optimizing when they are charged. This amounts to potential savings of 45 billion euros every year through 2030, when the IEA estimates there to be a total of 133 million EVs worldwide. We expect that utility companies are willing to spend up to this amount for smart solutions that solve the issue cheaper, faster, or with less disruption. Initially, we plan to focus on the German market, where we are most familiar with the regulatory environment. With 10 million EVs on the roads until 2030, as envisioned by the federal government, there is a savings potential with smart charging solutions of 3.4 billion euros. We plan to sell our service to 30 DSOs in Germany's 15 largest cities, where the impact of EVs on the grid will be felt first. This share of the market amounts to 100 million euros. Of course, we are not alone in this enormous market. A number of startups has already taken up the challenge of solving the charging issue, and they mainly differ in two different dimensions. First, whether they focus mainly on scheduling, also known as V1G, or work on vehicle-to-grid V2G solutions. And second, they differ by how sophisticated their optimization algorithms are. We have decided to focus on scheduling because it allows us to get started right now with the charging hardware already in place today. We are unique in that we solve the underlying optimization problem with a quantum algorithm. This enables us to optimize charging both at speed, in real time, and at scale for the steeply rising number of electric vehicles. So let's look at the road ahead. We founded ChargeQ in 2020. We are currently mapping our problem so that it can be solved on a quantum annealer, which serves as a proof of concept with the first customer. By 2021, we plan to solve the QBO problem with the QAOA algorithm on NISQ quantum hardware and release our service to the general public. Ultimately, we plan to run our algorithms on future universal fault-tolerant quantum computers, which we expect to be available at the latest by 2030. Reaching these ambitious goals would not be possible without the right people. Over the last months, we have formed an amazing team of top TUM students. Among us, we have expertise from quantum computing, software development, automobile strategy, and venture capital. Now we are very much looking forward to discussing our solution with you and answering any questions that you might have.
Perfect. Thank you very much, ChargeQ, for this great presentation. And we'll be going through the questions in the same way as we did before. Please use the raise hand function in the reactions button if possible. And otherwise, please just type into the text raised hand. Thierry? Please go ahead.
Thank you, Tom. Thank you, team, as well, for your presentation. 2 questions. First one, market pull. You talk about this being really suited for energy grids that operate very near at peak hours, that operate very near to their maximum capacity. What is that market size? How many energy grids today are operating during peak times at really near maximum capacity?
I can take that question. Very good one. It's not about when they, or if every of them is at peak or at capacity. But if you're only 15 minutes above the capacity, you will be paid the whole amount for the whole year. So if you remember the first chart, or one of the first charts, pictures, where you saw all the households, it's enough if you only go 10 or 15 minutes above that capacity in one day.
Okay, thank you. Second one, your solution. To what extent does a quantum approach bring a transcending advantage over classical approaches?
I can answer that question for you. So the problem that we're dealing with is in the broad class of scheduling problems. And there are many different flavors of those. And there are also many different approximation algorithms, as these problems play an important role in operations research. However, in the most sophisticated version of these problems, the job shop problem, the best state-of-the-art commercial and academic solvers today already struggle, as Viviana said, at about 10 machines and 10 jobs, and they completely break down at 20 machines and 20 jobs. So what we want to do is, first, we want to do this for many, many electric vehicles. So maybe, let's say, on the order of 100 electric vehicles in one subgrid. We also want to do this in real time, and we want to add many constraints. For example, we also want to optimize battery wear and for cost of electricity. And so this makes quantum computers, where research shows that they are really well suited for combinatorial optimization problems, uniquely positioned to do that better than classical algorithms.
Perfect. Thank you. Next up would be Stefan.
Thanks a lot. Thanks for the nice presentation, which makes me think that I should save my Tesla right now before my neighbor does. So the question would be actually, how do you bring people to actually use your app? I think there is quite a complication in that everybody then uses and puts in his timing in the app. So how do you make sure that this happens on a large enough scale?
I can take that question as well. Very good one. The target customer in this case, or the main target customer, is the DSO, so the distribution system operator, and a target customer is the end customer, so to say. So we have, Vivi, if you could jump on the promises, the ChargeQ promises slide, then it's easier to understand and to explain. Yeah, thank you. So the end user is not permitted to use our app. So the first, or the main idea or aim is to help the DSOs shaping or shaving the peaks. But the end user can use our app, so to say, as an add-on to make sure that their or her car is charged sufficiently when they want to departure. So it's a win-win. They don't have to use it, but if they use it, they have advantages. And the customer, the first and main customer, will be the DSO with the API we provide them.
Also, if I can add one thing to that, I just came across an article that the federal government is working on a bill, in fact, right now, that will allow DSOs to just randomly shut down people's devices, or like devices, for example, chargers, wall boxes, which use lots of power, if it endangers grid stability. So this is, of course, the worst case scenario, right? So people will have an incentive to use our app if they can avoid their wall boxes just being shut down randomly.
Okay, thank you.
Thank you. Next up would be Frank Willem Mauch.
Yeah, so I think Tom invited me as a quantum computing expert, but now let's ask a question from me as an electric vehicle driver. So you're clearly dealing in a market context that is extremely quickly evolving, that is extremely quickly changing boundary conditions. So how do you adapt to, is your approach seems to assume that you have one customer per area. So how do you deal with aspects like in any given town, there are between 5 and 10 companies that are operating wall boxes, that are operating charging stations, that wall boxes are partially fueled by electricity that people are making by their own photovoltaics, and by the fact that due to the extreme fluctuations of charging prices, the choice of which charger I go to also depends on that. There was a whole sports and EV driver circles to avoid, if I may call the name, to avoid ionity and otherwise go to a cheap provider. Is that adaptive with your model, and how does it generally fit these strong fluctuations of boundary conditions?
I can take this one again. Again, very good question. Thank you. So first of all, because the DSO is our main customer, we can go around the charging station operator problem because they have to handle their charging process with the DSO. So that's the question to the first point. So even if we have different charge point operators, they will be connected to the local or the next DSO. The second question is a very good one because that was our second use case we thought about in the beginning, to enter the energy market, so to say, and know when to buy the energy because of those changing and fluctuating prices. But right now, we don't have a solution for that and focus only on the scheduling of the charging process.
Yeah, thank you.
Thank you. Next up would be Christoph.
Yeah, hi. Thank you. Thanks very much for the presentation. I think you had been in contact with one of my portfolio companies, right, Pascal? I think they have published a paper on this one.
Christoph, unfortunately, we cannot hear you. Okay. It sounds very, very low.
Put it this way. Is it better now?
Yes, that's perfect. Thank you.
Okay, so I just put in the chat, I think, the work by one of our portfolio companies, a neutral atoms-based quantum computing firm. It's been working with a utility in France on smart charging for fleets of electric vehicles. So it might be some things there, both on QEL and some form of annealing, which is not exactly the case, but it's solving maximum independent set on the atoms directly. I think in the discussions I had with them, though, and the utility EDF, I had the impression that they told me they could go much further, up to 100 nodes, more or less, so vehicles or charges, not way more than the 10 that you've mentioned in your presentation. This seems very low to me. I understood there's a couple of very good algorithms, classically, that can help you solve this problem. So I'm a bit surprised that you put the threshold that low. So how did you do with your competitive analysis, and how did you came up with this number?
Yes, so that is right. We actually talked to the people from Pascal and had an expert interview with them. So yeah, thank you for giving us that lead. Regarding your question, so I was talking before about these different flavors of job shop problems, and this number 10 by 10, so 10 jobs on 10 machines, this is well, a problem size that in general job shop problem solvers start to struggle with. And then at 20 machines and 20 jobs, it becomes almost intractable or really difficult to find the optimal solution. So of course, these are not now we're talking about job shop problems with maybe many other boundary conditions. And as I said, there are broken down versions of the problem with less boundary conditions for which better heuristics and better approximations exist, right? So then we can also already today deal with larger problems, but we really want to incorporate like a number of boundary conditions to also, as I said, for example, minimize battery wear.
Yeah, okay. Thank you. And the second point is more a comment. So I have been working in the energy sector, distributed generation, at the time of deregulation of the market, early 2000s. And there's been quite a lot of companies created on load management. Many startups of every kind, in California in particular, or in Europe as well. I must say that one of the difficulties we had to face was to adapt to the rate structures in each geography. Also dealing with regulators, lobbying, and it took, for some it was really hard, very difficult to do that, and they shut down just because they didn't have the resources also to deal with that, with lobby and making the rates change, or public utility commissions take new technologies into consideration. I think that's something that it's a bit tricky. I mean, for one geography, I think that that can work. If you want to go global, might be that you have to take into consideration lots of different structures. Yeah, kind of vulnerability for the business model in my view, but that can be solved probably. But there's lessons to be learned from all the load management companies from the 2000s that have been created. Some failed, some made it. Yeah, maybe worth having a look later on.
Good point, thank you.
Thank you. Thank you.
Good, then we're going to have time left for 2 short questions. Corey first and Frank.
Yeah, hi guys. First of all, I want to say it's a really fantastic project and great presentation. My question would be, you said you want to release the product in 2022, I believe, on the NISC era machines. And so obviously it depends how you break the problem down, but how many vehicles do you think you'd be able to fit on one run of the annealing or the QEL algorithm? Because that also depends on what intervals you guys are charging at, right? So you're not using market data, which, you know, the intraday market trades at 15-minute intervals, but it depends how you slice things up, I suppose. But I'd be curious in how you see it scaling and already a product in 2 years or 1 year.
So yeah, we are going for 15-minute intervals. So this is how we slice the problem up in time-wise. And yeah, so for the QA/OA implementation we are aiming for, we are still experimenting with parity encoding. So we can't really say how many qubits exactly we need, which is, I think, in general, a tough question. And yeah, also our problem size will depend on what is available next year. And we all know that this can change very rapidly. So yeah, we have, yeah, in our expert interviews, yeah, there were hints that next year a lot bigger problems could be tackled, and yeah, we are excited how this might develop.
Perfect. And then the last question, as we're running behind on schedule, would be Frank.
Actually, my question was aiming at a very similar point. It's just assuming some realistic case that you would like to manage, how many qubit and what kind of circuit depth would you actually need, or like for a realistic case? I mean, say for a grid of the size of Munich, how many qubits, what size of quantum computer would you need?
Yeah, so as I said, for the real solution we are aiming for with the QA/OA solver, we are not yet ready to figure this out, but I think that the annealing implementation with a size of 9 jobs and 9 machines took 2,000 qubits. So that's quite large, but we don't really know how far we can go with parity encoding.
Okay, thanks.
Perfect. Then thanks again to ChargeQ for this great presentation and handling the Q&A. And at the same time, please, QDynamics, please start sharing the presentation. QDynamics was the startup that had Airbus as a challenge partner. QDynamics, please go ahead.
Hi, we're QDynamics and we're excited to show you the vision for our startup. Simulating the flow of air and its interaction with different objects like this plane here is a critical undertaking for a lot of companies in different industries like the aerospace industry or the automotive industry. This process is also known as computational fluid dynamics, or in short, CFD. So what is actually the problem that we identified in this industry? Imagine you're an engineer working at a big airplane manufacturer and you've just come up with a new wing design and now you want to test it for its performance in the air and its structural integrity. When you want to upload it to your favorite CFD software, you immediately recognize that it's way too complex and big to simulate it in a reasonable time. So you have to split it up into smaller parts and simulate each of them individually. Even when you have access to the best supercomputers in the world, this problem is not alleviated. And also there are really long idle times between design iterations because simulating one part can sometimes take weeks or even months, which is a ridiculous time in our opinion. So in summary, the current challenges are that the size and the precision of the models that can be simulated is severely limited, and that limitation stems from the amount of meshing nodes that are used in those models. You can see those meshing nodes in the picture on the right, and those meshing nodes are currently limited to 10 to the power of 9 meshing nodes. This granularity in meshing nodes is needed to actually capture the subtleties in the airflow. Secondly, as I just illustrated, there are really long runtimes, and all of this leads to the necessity of expensive physical testing. So the engineers have to resort to renting physical facilities like wind tunnels, and then that can run you thousands of dollars per hour, which is really expensive. So the problem that we want to solve in one sentence is that aerodynamic simulations are heavily constrained by the accuracy and the speed that can currently be achieved with solutions based on high-performance computers.
So how are we going to do this? We are developing a software that makes it possible to have more accurate and rapid prototyping for the aerospace industry by increasing precision and reducing the runtimes of aerodynamic simulations. We do this by leveraging the power of quantum neural networks. With neural networks, we can directly model the functions described by so-called partial differential equations, or PDEs for short. This is a very complicated type of equation that is involved in aerodynamics calculations. And while these equations usually are calculated step by step, which gives us the need for the meshing we just mentioned, our solution doesn't need step-by-step calculations and thus makes simulations way faster and easier to use. Also, while using quantum computing, we can speed up the process even more and make the function models more accurate, giving better results when modeling airplane design components. We are aware that a patented method for using quantum neural networks to solve differential equations exists. And if we use this exact method, it will imply us having to pay licensing fees. We are currently investigating the overlap between our method and the method that is patented, and are in touch with the company who developed this method. While this all sounds very complicated, using our software is actually very easy. On our website, just hit the Start QDynamics Power Simulation button. Then in the top corner, you can upload your model of the entire airplane wing. No need for scaling down or dividing it into smaller parts. Then you just enter the settings you always enter when you use CDFD software and hit the Start Simulation button. And voila, after a few hours, you have your solution. This took way less time than traditional software, which can take up to days or even months when solving these equations.
Our main goal is to make CFD simulations faster and more seamless for the user. By using our solution, the runtimes become smaller, meaning that less physical testing is required. Engineers get to do more iterations on their product and therefore have reduced time to market for their new components. Less physical testing also results in significant cost reductions, while also benefiting from accurate simulation results. By not having these meshing constraints anymore, the users suddenly have less parameters to fine-tune, which helps us provide them with a more user-friendly experience. Now, I've mentioned the users quite a few times, and that would be the aerospace engineers. They are limited by the design process by the large simulation times required. They also need no previous knowledge about the inner workings of CFD simulators or even about quantum technologies. On the other hand, our customers would be either CTOs or PMs in companies or teams that heavily use CFD technologies. Their main goal would be to improve how efficient their engineers are working and also to stay ahead of the competition and keep track with technological advances. While the topic itself is interesting, it is also worth it from an economic perspective. In 2020, the total CFD market was over $4 to $5 billion US. In this market, we can expect a value gain of more than 600 million by error mitigation using quantum solutions, this being our serviceable available market. Finally, assuming a 4% market share, based on revenue projections within the EU and targeting the aerospace industry, our serviceable optimal market amounts to 26 million. This alone is a very promising market already, but is also constantly growing. The compound annual growth rate was over 9% in 2020. Quantum computing is also expected to have a huge impact on this industry. According to the Boston Consulting Group, value creation in the CFD industry is expected to reach anywhere between 19 billion to 37 billion US when we finally reach full fault tolerance.
As you just saw, this market offers a huge potential, and therefore it is crucial to have a well thought out go-to-market strategy. We as a company want to grow with quantum and therefore start out with an API for a PDE solver, which can be integrated into existing CFD simulation software. For the API, we opt for a pay-as-you-go pricing model, and then later on switch to a subscription-based pricing model once we offer the full software solution. We also have great contacts to major players in the field like Airbus, which is a huge opportunity for us to quickly become known in the industry. Let us now take a look at our roadmap. As I just mentioned, we want to start out with an API and build up on that to deliver a full software solution by 2024. We then want to set out to other industries by 2028 and tackle an even bigger market. We expect a full speed up of our CFD simulation software by 2030. Inherently, this is strongly dependent on the actual development of quantum computers in the near future. Let me show you our software development timeline. Our team just started this journey, so we are still in the development phase. After the proof of concept and setting up the infrastructure for our API, we want to develop our MVP by October of this year. We then enter a final 3-month beta testing phase, and we're already excited to launch our MVP by the beginning of next year. The reason why we are going to make this work is our great interdisciplinary team. Together, we want to bring quantum to the people. There's Yannis, our software developer. There's Gabriel, our software developer, Yannis, our CEO and business developer, Karim, who takes care of finances and sales, Danielle, our algorithm specialist, and myself, the quantum developer. In the near future, we also want to expand our team to accelerate software development, and we will also need help in our sales department. Thank you very much for your attention and giving us this huge opportunity to present our vision to you. We are happy to answer your questions now.
Thank you very much for the nice presentation, QDynamics. And with this, we will proceed to take questions. The first hand that I see is that of Christian, so please go ahead.
Yeah, my question or concern would be about large numbers of degrees of freedom, so to say, which you typically encounter in such a fluid simulation problem, right? So as you mentioned, there are like millions of parameters or variables in such a solution or problem. And the question is, how do you plan or imagine to get this into a quantum computer, so to say? So even, get the data from and to a quantum device, so to say.
Yes, so our our solution uses an approach called physics-inspired neural networks. And with this kind of neural networks, you take the neural network and it basically learns the function that the equation describes directly without the differentiation in it, just what it would be like if you hadn't a differential equation. And to learn this function, you don't need these meshing nodes that are usually used in classical methods, but you can just take some of the sample some x values and then calculate their function values directly. So you get rid of like all the numerical things you need to do. And that makes the problem a lot smaller. And so
Okay,
a lot easier to fit on a quantum computer. Although it definitely will be a challenge to do that, to fit it on a quantum computer, which is why we want to start off with a hybrid solution, or maybe even one with only quantum simulation first. We're currently investigating tensor networks for that purpose. Does that answer your question?
Yeah, I have a related question, but maybe let's take the questions of other people first. Okay, but thanks for your answer. Yeah.
Good. Thanks a lot for your question, Christian. Next up, Elvira, please go ahead.
Thank you very much. Very interesting presentation. So my question mostly related to the concept. Why this particular choice of solving the PDEs, or the choice of using neural networks for solving PDEs? And the second question is, have you checked on the other methods? Because even in, for, well, quantum methods, I mean, so there are some of them which are also based on the discretized representation of derivation operators, or there are some recent papers on the continuous derivation of the quantum circuits. So why this particular choice of quantum neural networks, and what's the advantage? Have you checked on the advantage of this method compared to the other strategies, for example? Thank you.
Well, we stumbled across a paper about these physics-informed neural networks, and we thought it was a very interesting approach. And also we don't have the need of meshing sounded very interesting to us. And maybe could you repeat your second question real quick for me? Sorry.
No problem. So what is particular advantage of using the quantum neural networks applied to the discretized problem compared to some other known and maybe recently even published methods that use, for example, discontinuous derivation of the quantum circuits, or that use also like the discrete representation of derivation operators, sort of the quantum analogous or finite difference approaches, something like that. So there are some methods which are published for solving nonlinear problems, etc. So the question is like quite broad. What is the advantage of this particular choice compared to other techniques? Maybe not now, but probably in future perspective, because now it's really complicated to find out what we best.
Yeah, sure. So for one, that we don't have the need of a meshing is a huge advantage for us. And then also that we expect a quadratic speedup with our approach to the classical approach. So we think it is already quite good. If this answers your question.
Oh, okay. Thank you.
All right. Thanks for your question, Elvira. Following up, Corey, please take the stage.
Yeah, hi. So again, great presentation. My question is more coming from the software side. You said that you would integrate, so you want to define an API, and then you have these CFD simulators. So admittedly, I don't know really what a CFD solver is besides what you showed us in the nice little demo, but I assume, so is this a common technique where software providers provide these CFD solvers and they've already made a API possible where you can, I don't know, take your your problem variables and then submit it in some way in a file over an API. So how common are these types of CFD solvers? Can they all do that? Or are you kind of restricted to potentially only working with a specific brand of CFD solvers? I don't know. Can you speak more on that?
So generally, CFD simulators tend to be very specialized depending on who and what they're using the CFD simulator specifically for. Usually big companies have their own in-house products. There are also open source software solutions. For example, OpenFOAM is a very popular open source CFD simulator. We were mainly thinking for the first phase developing the API, making possible a CFD simulator, and then for big companies trying to integrate our API into their solution with a more personalized variant, and also making this API available selling it as a product, online as a SaaS product. That was kind of our plan for the beginning, and then fully developing it in a full software product later on.
Thanks.
Hi team, thanks for the presentation. Question about accuracy. Finite element method is indeed slow and power hungry when it comes to the computation, but can give very fine mesh, very accurate distribution of information. Can you comment a little bit about your approach and how you would deal with perhaps limitations in accuracy, especially for the aerospace sector, where certification and being able to demonstrate convincingly results is important?
So our idea was that the first version of our product should be used for prototyping, meaning that if you have a lot of different designs you want to test, you can get an estimation of the aerodynamics values for them very quickly with our product, and then later move on to with the few best solutions you come up with to more accurate versions of software or to physical testing. And as for the accuracy of our solution, so once you increase the size of the neural networks, the physics-inspired neural networks, they will become more accurate in the sense that you'll be able to model the functions more accurately. But they also become slower, but when using quantum, we can speed them up. So we kind of outweigh that disadvantage in the future. And also quantum neural networks there are papers reporting that quantum neural networks give more accurate results than classical ones. So that's also a point how we increase accuracy. So in the end, for our final product, we want to come up with the same accuracy rate, so to say, as current products that use finite difference methods.
Thanks.
But of course, it's still a trial and error process for us to develop that.
Thanks for your question, Thierry. Now, please, Guillaume, go ahead.
Sure. The interface looked really good. The website and all that. I think this is an area of very explorative research at this stage, whether machine learning approaches or even quantum approaches could help with differential equations. But it's certainly an area of that warrants further investigation. I would consider it more of a moonshot, but if it works, I mean, it definitely changes the game for high performance computing. So I think I looked at the paper that you referred to. It's more or less using quantum neural networks as feature maps, which can be interesting. I think in terms of areas of research, currently some are looking at reservoir computing, which is using chaotic dynamics of systems and kind of using a reservoir of chaotic dynamics and embedding and getting expectation values out, which is basically what this paper is doing. Actually, that's been shown to achieve state-of-the-art to model chaotic dynamics of, say, like fire propagating, which is a plasma and fluid dynamics. It's somewhat related, at least. So there is actually a potential for an advantage here. And then the point would be that quantum computers exhibit quantum chaotic dynamics that cannot be simulated with classical devices. And then the question is, can you show separation between these echo state networks or these classical reservoir computers and kind of quantum reservoir computing. But even then, I would say just exploring the potential of machine learning and leveraging reservoir computing and making a platform, even using classical resources, already I would say there's probably not many people doing that. So that would already be interesting. And you seem to have a nice API. It looks great. And if, ultimately it's not about I use quantum computing, it's about how much value do I add to the customers and their workflow. So I guess focusing on that, and then, quantum is kind of the dessert at the end of the meal. It's not shouldn't be the main dish. It's like a nice add-on. So I would say keep it up. It has potential, and yeah, feel free to reach out if you're interested in testing research ideas.
Thank you very much.
Will. Thank you.
And thanks a lot for the question, Guillaume. This was the last question for the current team, QDynamics. And with this, we're moving on to the last team of the evening. Team ElectriQ has been working hard on a solution that aims to increase the reliability of our grid. As our colleagues from ChargeQ were already explaining to us, the introduction of new renewable energy sources lead to instabilities that can, in some situations, lead to faults in the grid. How they tackle the solution, they're going to be better at explaining it. So please, Team ElectriQ, feel free to take the stage.
Thank you, Raul. Okay, we are Team ElectriQ, and we empower network operators with quantum-correct analytics. We use electricity every day, and we need it for most of the things that we do. And we are provided with electricity from our local energy provider. But that's not only the case for us. We live in a neighborhood with many other households that also use the electricity of that same provider. In fact, that neighborhood is not the only one, but is part of a more complex structure of even more neighborhoods that are all interconnected with each other. If this complex network is not maintained correctly, we could face power outages. However, responsible for minimizing the length and occurrence of these outages are grid operation managers of transmission system operators and distribution system operators. They are the responsible managers to reduce the risk for end users like us. What they currently do, they look at the single asset of the grid, for example, a transformer, and based on individual features of that asset, for example, weather, location, fault history, and many more, up to about 40 features, they maintain the grid by prioritizing the maintenance budget to fix faulty assets. However, if an outage occurs, they face costs or even penalties. What is not taken into account in this approach are neighboring infrastructures, including many more features. And if a fault occurs, that power needs to be rerouted, and thus we need to consider more features of the entire grid. However, this quickly becomes a huge data load, and thus we face the limits of classical solutions to calculate the rerouting of all assets and their features. And this is where ElectriQ comes into play.
We at ElectriQ have developed a solution to apply classical and quantum algorithms in order to prioritize asset maintenance within the grid. Now let's take a look at our product. As a user, the first thing I see in our product is a job queue. Here I can add a connection to my data set, choose which type of algorithm I wish to run, select the architecture, and finally choose the algorithm to analyze it. We can see that a warning also appears if the dataset is ruled to be too massive for a classical model to be sufficient for a full analysis. I can now see the job status in the queue where it runs until completion. Now I can go to a map view and see the results of our analysis. At the top, we have an overall summary of the grid. The neighborhoods of my grid are plotted on the map colored by their risk category. Each neighborhood is defined as all the assets between two high voltage transmission lines. We also generate a sorted list of their severity ratings determined by our analysis algorithm. I can click on a given neighborhood to see its individual assets, such as wires and transformers, where the algorithm has also applied traditional asset fault prediction. Clicking on individual assets gives us more information about the features that were considered in the analysis. This gives us an all-in-one solution where once the severity is determined, I can analyze individual assets and make further decisions about maintenance. So how do we do this, and where does quantum come in? We look at our entire network where we simulate neighborhood outages and the rerouting of power to nearby neighborhoods. This in itself can cause a chain reaction of power outages. The data of this newly generated network is then merged into one single data point. This data point contains all features from all assets within the grid. We repeat this operation until all outages, including multiple simultaneous outages, are simulated. Working with these points becomes significantly more complicated than analyzing a single asset, significantly more complicated than a single neighborhood, and working with it begins to become infeasible for classical models. What we do is apply k-means clustering to these data points to cluster outages into risk categories. If a certain neighborhood with potential faults appears often in outlier clusters, then we know that it is a critical area and we give it a high severity rating, meaning maintenance here should be prioritized. As the number of features that we consider grows, the time to do this calculation increases linearly for a classical model. However, quantum k-means is logarithmic. Now, taking a look at this graph and remembering that we are considering a significant number of features, the time required for the quantum algorithm begins to exponentially outperform the classical algorithm. So much so that the classical can no longer create these severity ratings without significant shortcuts, such as removing many features. The goal here is that we can currently implement a classical version of determining the severity rating, although with simplifications as needed, as well as a quantum version which will consistently improve as the hardware becomes available. Instead of asking, how many qubits do we need for this? We can look at it as how many features of the grid can we consider each time new hardware is released. Through QCware Forge, we were able to implement our own quantum k-means algorithm on a quantum simulator and use QCware's clustering algorithm on the Rigetti quantum computer as a first proof of concept. There's no black magic involved in this process. It's not just a theory whether this quantum algorithm works or not. It's proven, and it only requires a team with the right expertise to make it happen.
Now, let's take a look at how the grid operations manager benefits from our solution. First, he can prioritize assets more accurately, thus minimize the number and impact of outages. This results in a reduction of the KPI SAIDI, which represents the average outage duration for each customer served. This KPI considers the total number and duration of outages and the total number of affected customers. This is the number that TSOs and DSOs must submit to the government. A SAIDI below the average compared to other network operators results in a regulatory bonus. In addition to this, the reduced outages lead to further savings in operations and maintenance. For our software, we have calculated an average price of 30,000 euros per year, based on the average savings that our software can create. In addition to this, we'll offer our customers with additional services, such as the initial data setup, additional consulting services, logging access for multiple users, and customized features. For our product, we have calculated a total addressable market of 1.78 billion euros and a serviceable addressable market of 202 million euros. This is based on the average revenue per customer multiplied by the approximated number of customers in Europe. And by 2025, our goal is to obtain a 6% share of the European market. This number is based on our revenue projections and taking into consideration that our partner E.ON owns 16% of the entire electric network in Europe. In the long term, we will expand our solution to other energy distribution sectors, such as gas, water, and heating, increasing our total market size. So, where are we right now in our journey? So, as of now, together with E.ON and one of its subsidiary DSOs, we have implemented our first k-means and quantum k-means algorithms. By the end of this year, we plan to finalize an MVP. In parallel, we will partner up with a quantum computing company and continue improving our quantum implementation. By 2022, we will roll out the classical solutions with further E.ON subsidiaries in Germany. For the next few years, we are planning to scale our company and offer our solution to other European DSOs. And by 2025, we expect the quantum computers to be advanced enough for commercial use and for a rollout of our quantum solution. The question that might follow is, why now? Why not wait until 2025 to start our company? So first, there are very few competitors offering AI-based grid analytics. We can gain a competitive advantage by positioning ourselves as market leaders. Secondly, we are currently seeing an increase in smart sensors, partially driven by governmental regulations, increasing the total amount of available data. And finally, we are further developing our quantum algorithms so that we can just deploy them in time with the commercialization of cloud quantum computing. Our team consists of 5 talented and motivated students with diverse backgrounds in software engineering, quantum computing, and entrepreneurship. We are Team ElectriQ, and we are on a journey of empowering network operators with quantum computing. Thank you so much for your attention, and now we are happy to take your questions.
Excellent. Thank you very much for the great presentation to the whole ElectriQ team. Before actually jumping onto the question, I just want to make a short remark. After this Q&A round, we are going to be having the outro, but straight after that, we are going to have the opportunity to actually split the current Zoom call for the ones that are following us over the Zoom call into different breakout rooms, in which in each one of them there will be one of the teams, and you will have the chance to ask any additional questions that you didn't have enough time before. And as the organizing team will stick around in the main room, so you also will have the chance to ask any questions that you may have. And with this, I give the microphone to Andre. I can see you already raising your hand.
Thank you, Raul. A great presentation again. You mentioned at one point that there's no black magic. This algorithm is proven, and on Rigetti on top of that, I'll leave it up to some of the smarter people than I on the jury to challenge that. My question again about the market size and your business model, where I'd like to dig in a little bit. And it seems to me that your product, the way you presented, might constrain your value. You showed a very nice MVP, very impressive. It seems reactive and prescriptive. Can you talk about your product roadmap and upcoming features a little bit? Do you have predictive capabilities in your roadmap? Further analysis, is there potential for automation that might increase your value proposition?
Thank you for the question. So right now we have some fault prediction algorithm developed by our partner Eon. So right now we are taking that into consideration in our algorithms, in our products. So that's already solved, and that's why we are focusing on the next step, which is solving the problem of how to prioritize the asset maintenance more accurately by taking into consideration the entire electric network grid. So that's our first priority. And with this, actually, we solved the problem for the grid operations manager, because he only wants to know which assets to prioritize first. And he's not interested into many other features, such as understanding what's really happening behind, maybe only about the overall data. But that's basically it. So the grid operations manager has the software, assets that are ranks in a list, and then he knows how to schedule those assets. Maybe we could think of further features, such as this part of dispatching service technicians and scheduling them and so on. But right now we haven't focused on this problem, but of course there's a larger market size considering also those features.
Thank you very much, Luis.
And thank you for your question, Andre. Then following question, I cannot see any hands currently. So Stefan, and then Christian.
Can you please comment on how powerful the quantum computer should be in 2025 so that you really get a break even in terms of the quantum advantage that you need? Because the algorithm scales basically polynomially, and you get hopefully an exponential speed up, but the original algorithm is is already scaling only polynomially. So how large would the quantum computer be?
I can answer this question. So one of the benefits of this algorithm is this distance metric doesn't have to be 100% precise to be able to cluster with some ability. So because the number of features that you can store in qubits grows, I mean, you can store a vector of length n in log n qubits. The size of the quantum computer is kind of like, yeah, as how can I?
So I think Stefan dropped. For a second, let's give him a couple of seconds, or if any other team member wants to take the question.
I can take it. So your question was how large of a quantum computer we need, correct? So the idea is, as the number of qubits becomes available, we're able to scale the size of our feature vector, meaning that essentially now we're only constrained by however many qubits are available currently. So we just decrease the number of features we consider. So instead of needing a hard limit on the number of qubits we need, we can just, as time goes on, we expand that feature vector and get more accurate and more usable data, or more usable results.
Okay, thanks.
Good. Thanks a lot for your question, Stefan. Now, the microphone is yours, Christian.
Yeah, I've also another question on the algorithmic side, so to say. Just correct me if I'm wrong, but do I understand this correctly, that you want to find, so to say, clusters of assets in this electric grid, which would be highly susceptible to a failure, for example? I mean, just to get the point or a main idea of the algorithm is idea to identify, so to say, things which are outside of the norm. And the related question would be, how do you deal with, I mean, the kind of a lot of different behaviors or properties. Let's say you have some transformer. I mean, I'm just guessing now, just to give some example. You have a transformer, and then some, you mean a lot of different types of devices in the grid. And how do you kind of deal with this variety of devices?
So when in the beginning, we curate the data set essentially, because we know there are certain features that are more likely to create these failure clusters. So we would consider all assets, which is the plan, but we would only consider certain features that lead towards fault detection. You might not need to consider, for example, longitude and latitude, because otherwise it would cause a cluster of just geography. So by curating essentially what we're considering, we can make it where that our clustering algorithm gives us really a failure cluster. I don't know if that answered maybe both of your questions, or.
Yeah, okay, yeah, that sounds good, thanks.
All right, thanks for your question, Christian. We have room for one more question, and otherwise we will just call it a day. No? All right, then I guess that everybody was pretty impressed. Thank you very much for your questions and also for the excellent presentation. And with this, we are finally done with the pitches, these greatly exciting pitches. And it has been a real pleasure being able to watch the excellent and delightful work that the students have put out throughout the semester. I have seen persistence, and I have seen a continuous improvement day after day. And the final presentation does nothing but conveying this continuous work and great progress of the teams. So congratulations to every and each of you. And now I will share screen again. Good, excellent.
So maybe from my side, Raul, Tom, and all the team of PushQuantum, many thanks from our side. These were really great presentations, and to all presenters, and also the jury, also from the academic advisory and leader team. Many thanks to you.
Thank you very much, Stefan. And I can nothing but throw this back to you. This is exactly what we were gonna get into, that we are insanely grateful by all the support that we have received since the very first day of this project. On the first hand, I will say that the protagonists today are the students, and they have been crucial in making this happen, because without having the teams pushing hard in their projects, we couldn't be here today. We also owe a lot to all the support that we have received from the different stakeholders of our ecosystem. Probably even the organizing team wouldn't have get to meet each other if it wasn't for the Bavarian Quantum Computing Exchange from the LRZ, or by the different events of the MCQSD. And then we were really talking about organizing such a course, but it wasn't until we had the chance to discuss with the different professors of the TUM. And also we received some support from the Venture Labs initiative when this really started taking off. So this course was a real community effort. And we want to close by just thanking everybody that made it possible, like the different challenge partners, the lecturers that came here every single Monday to provide with fresh information about the state-of-the-art research and also interesting market insights for the teams to be able to make significant improvements to their quantum products. Also, we want to thank the jury for taking the time to join us today. And we want to thank deeply to the teaching assistants of this course that have spent countless hours in the coaching sessions and also helping out the students further polish the great quantum products that they have been doing throughout the semester. And last but not least, I also would like to thank the rest of the team at PushQuantum that has been working together with me in making not only the Quantum Entrepreneurship Laboratory, but the whole initiative possible. We've been around for about 1 year by now. And I will say that I could never expect to be privileged enough to be sitting in the room of experts that we are right now. So thank you very much, everybody. Once again, I won't get tired of saying it. And with this, I just wanna start the different breakout rooms. Congratulate the teams again for the great job that they have done. And asking every of you that may have further questions or just wants to hang out, to just stick around. Last detail, we are probably super excited. The evening has been great. And now, what do we do with this energy? What do we put it in? Let me state it once again. Students, you can make more out of this. You can keep learning about quantum technologies. You can keep connecting with your quantum peers by joining our community. We are readily available to receive your different questions that you may have and to get you in the loop, and not only for participating in the events, but also for making the events happen. And by this, you will create opportunities not only for your peers, but also for yourselves. And we're already in the process of deciding who will be driving this initiative in the coming year. As this is a student organization, the board will be rotating on a yearly basis, and we will be delighted to receive your applications if you want to take a crucial role in shaping the Quantum Munich. Industry, academia, and startups, representatives of them all, please contact us if you think that what you saw here today deserves some further support and you would like to see this on other well-renowned universities of the world. Just reach out to us and we will get you in the loop regarding future editions of the Quantum Entrepreneurship Laboratory, both in Munich and around the world. And if you want to support us further in the international scaling, we would be also happy to discuss with you. With this, now we are really going into the breakout rooms and we are finishing off the YouTube live stream. So also thanks to everybody that has been following us on YouTube, and see you on the next events of PushQuantum. For the ones in the Zoom call, we'll stick around for a bit longer. Thank you very much and have a great day.